number 10. A cone of base diameter 70 mm standing upright is cut by a section plane such that true shape is a parabola of maximum double ordinate 50 mm and the vertex is 70 mm away from this ordinate. Draw the front view, top view and true shape of section. So this is the question. A cone is being cut by a section plane and the true shape is a parabola. When we are getting a parabola, how we are getting a parabola? A cone is when cone is cut by a section plane parallel to its generator. So this is the generator. This is one of the generators. So parallel to this generator, if we cut using a cutting plane, we will get a parabola, and the base will be cut always in this position. In order to get the parabola, always a cone has to be cut. The base of the parabola, base of the cone has to be cut by a section plane. So section plane cut such that the cutting is parallel to the generator. Now the double ordinate from this point to rear point, it is 50 mm, and from that double ordinate this point is 70 mm. And another peculiarity of the cutting is that always distance between these 2 points and this point will be same. If you cut in another position also, always when you cut the cone parallel to generator, always the length of the cutting plane and from this point to that cutting point on the other generator will be equal. So this distance and this distance will be equal. So from this distance is 70 mm. So this distance also up to here it will be 70 mm. This distance 70 mm and from here to here this distance 70 mm. We cut using another plane, maybe a cutting plane cuts here and here, this distance and this distance will be same. Now how it can be drawn? First you have to construct the top view. Top view is a circle. Its diameter is 70 mm. We are not given the height of the cone. Now these two lines are drawn from the center line at a distance 25 mm, so that from here to here it is 50 mm. This line and this line are drawn at 25 mm taken from this center line, so that this distance is 50 mm. Now project from, it is at the bottom, the cut is at the bottom, that point is here, that cutting line is here. So taking 70 you draw an arc, and now from here also you draw an arc, so that it will intersect at this point and join this point and this point and extend to get the apex of the cone. This is the axis in the front view. So this point joined to this point and extended to the axis, so that you are getting the height of the cone, and this point is joined with this point. So this becomes the cutting plane. So its designation has to be changed to H-type plane. So this should show the vertical trace of the cutting plane. Now you choose different points on this cutting plane. So actually at what distance this point is from the axis of the cone? Actually this point is this much distance from the axis of the cone. and this point is at a radius of this much distance from the axis to the outer, and this point is at what distance from the, is 31.31 mm away from the axis. So the corresponding points, how will you obtain the top view? From the center of the top view, you draw an arc having same distance, so that you will cut at 2 points, one at the rear and one at the front. This distance you will be taking in the compass and projecting from this point, from pointing on this center, you will cut 2 arcs. Example, if you want to get point 2 corresponding to 2 dash, 2 dash is here in this cutting plane. What we will do, from this axis, this is the axis, this is the axis, from the axis you draw a horizontal line through 2 dash, so that this distance, this is the radius, at that distance the point 2 is away from the axis. So you take this distance on a compass, fix one leg of the compass here, from 2 dash you drop a projector with the center of the cone or center. You cut the projector drawn from 2 dash at this point and this point, so that you are getting 2 and 2 in the top view. Similarly 3 dash, corresponding to 3 dash, you will have 3 and 3. So how that will be, 3 and 3 will be drawn from the axis. You draw a horizontal line through 3 dash up to the outer generator. So this is the radius at which point 3 dash is staying on the surface of the cone. So from 3 dash you drop a projector with this as center, this much as radius. You cut this projector at 3 and 3. Similarly 4 dash, through 4 dash you draw a horizontal line from the axis to the outer generator. Take that radius, this is the center, and cut this point, the projector coming from 4 dash. So 6 is always here on this generator. Corresponding to this generator, this is the top view of that generator. So just project from 6 to get this point. So by a freehand sketch you draw this one. Now we have to draw the toe shape. Actually from the top view we can understand that this figure, this section is symmetric about this axis. So parallel to this cutting plane you draw the axis of the parabola. Newly generated section is having a parabolic shape, and the double ordinate, maximum double ordinate is 50 mm. Actually that is this one. So first you draw parallel to this cutting plane, you draw the axis of the parabola. So this axis is nothing but this in the top view, this axis in the top view. Now when you draw the projector from this point, you take 25 to either side. This distance is 25 mm, this distance is 25 mm, total 50 mm. Now when you project from 2 dash, it's a perpendicular from the cutting plane. From the axis you take this distance. This distance you take on either side, to that side and this side, so that you are getting 2 and 2. Similarly from 3 dash, you project a perpendicular. From the axis you take this distance and this distance. 3 and 3 you are getting. Similarly from 4 dash, you project. What's the distance you have to take? From here to here, this distance you have to take. So on either side you are taking. And now join all those points, you are getting a parabola whose maximum double altitude is 50 mm and this vertex is 70 mm away from the projector, away from the double alternate. So same process is shown here. Radius is taking from the front view. With this center you are drawing an arc. Instead of drawing arc, we are drawing a circle and we are determining the cutting points. Once all the points are obtained, we will be by a freehand sketch will be drawing the joining all those points. Now we have to draw the true shape. For that we are taking the axis of the cone parallel to the cutting plane. This line and this line will be parallel. That is 14.57. That will be taken 14.57 to either side, to that side and this side. We will mark those points. Next you will take, that is 10.67. That distance we will take from the point. This is 10.67 to either side. Now join all those points using a freehand sketch. So this is how we are getting the solution.